Now, you guys don't have to do any guesswork on this one because it tells you this is cosecant. What other function could this have been? Secant. That's right. Do you guys remember the parent functions for these dudes? For secant and cosecant? Let's graph them out really quick. Here is one of the parent functions. I'm going to graph a shadow of sine, and then I'm going to put my asymptotes right there, and right there, and right there. Wherever we cross the midline, you get an asymptote, and then I draw my little parabolas. Yay. Okay, so what's this one? If we're going off of secant or sine, what is the graph of what I just did? Oh, you guys don't remember? Sine starts with S, so his reciprocal function must start with C. That's just a dumb rule I made up. So this is cosecant right here. This is cosecant X because he runs off of sine. The creepy shadow sine. Oh, stop it, you're weird. Okay, next we got the cosine. I'm going to graph the shape of the cosine. The cosine starts with a max, okay? The sine starts with the midlines. All right, then I'm going to draw my cute little, what are these called? Asymptotes. And then we have our cute little parabolas. So what is this dude? What is this graph? Yeah, this guy is secant. Okay, and the shadow right here is cosine. Oh, no way. Okay, but this one for sure we're using, we're making one for cosecant. All right, so that means we're staring at this dude right here. Now look at this, look at this, look at this. You see that, this asymptote right here? I want to use him as a reference point, all right? So, do I have an asymptote right here on the y-axis? Yeah. Hey, that's really cool. That means we didn't have to do a phase shift. There was no phase shifting going on. So I'm going to put 0 for phase shift. My asymptotes, oh dang, that's a lot of asymptotes. Look at all those asymptotes. Oh, I wish there was a fast way to write this. There is. Okay, what's your first asymptote? It's at x equals 0, right? Right? Now, what do I have to add to get to my next asymptote? So here's the asymptote right here. What do I have to add to get to this one right here? And then this one right here. And then this one right here. Does it look like 1? Are we just adding 1 every time? 1, 1, 1, 1. Hey, it kind of looks like that, huh? So let's just do this. Let's just say it's plus 1. So you could start, actually it's plus or minus 1, huh? Well, I'll just say plus 1, and I'm going to put an n right here. N is an integer. Okay, meaning we can put like a 2 here or a -2, whatever. Because if we move 2 this way, 1, 2, we get an asymptote. Or if we move 2, -2, we get an asymptote. So no matter what, and the n is, these are your asymptotes. Okay, but now we get to the hard part. I think that stuff was all simple. Okay, but the hard part is, what the heck is our period? All right, now if you guys didn't know, this is pi over 2. That's pi. This is 3 pi over 2. And this is 2 pi. All right, that's just a side thing. All right. And then what is that called? That's a sine. So sine's going like this. Now you can count a period on sine by going from midline to midline, like when it finishes. All right. For cosecant or secant, you can go from the maximum point on sine to the next maximum point on sine. You could do it that way. Or you can go from asymptote to not the next asymptote, but the asymptote after that. Because that's when the graph starts repeating itself. But that's the whole point of a period. The period tells you when the graph starts repeating itself. So what is the distance on the x-axis that where the function starts repeating itself? That's right. We're going to say 2. So 1, 2. That's what it takes to get to the next asymptote. So I'm going to put a 2 for my period. So now the question is, how the heck are you going to write this dude? All right. Well, it doesn't look like. Let's see. It looks like you see my shadow right here of sine. it looks like we're just going one up from the amplitude for the midline. So our amplitude for sine would be 1. Cosecant doesn't really have an amplitude, but you know that number does change how high and how low the shadow function goes. And then we definitely don't move up or down. We don't do any shifting up or shifting down. Our question is, what the heck is this number right here, the omega? The number that's multiplying to the x, because that is what it gives us our period. So let's think about that for a second. What is the period normally for cosecant? It is 2 pi. And what you would do is you would take the omega, whatever is multiplying to x, divide the 2 pi by it, and that would be your period. Well, since we know the period is 2, let's go 2 pi divided by omega. We know the period is 2. So can you guys just, by looking at it, tell me what the omega is? It is pi. Now, if you couldn't, let's pretend you couldn't recognize it. You could do like cross multiplying, or you could just multiply both sides by omega so that these cancel out and you're left with 2 pi equals 2 omega. And then to get the omega alone, you have to divide by 2, so you get pi equals omega. So we know the omega is pi. And I can write it just like that because there's actually no phase shift, so I could put a 0 right here. If there is a phase shift, you need to make sure you multiply the omega to that also. But we don't have one. All right, so what is our y-intercept? Our y-intercept does not exist, or you can write none. And then our x-intercepts looks like, nope, we don't cross the x-axis anywhere, so we can write none or does not exist there as well.